Hello, you're welcome to Quiver Analytics, and this is the data science project demonstration with IBM SPSS. And it's a webinar, and you are all welcome. All right, now you can please do well to follow us on all of our social media platforms. If you are watching, you're probably on YouTube, and don't forget to like and subscribe. Follow us on Instagram, on LinkedIn, on X, on TikTok, and Threads, Gmail, WhatsApp. All right. Okay, so if you're watching this, you should have these documents and what we offer trainings and services in business data analytics, scientific data analysis, database engineering and administration, and all using all of these tools. All right. So I don't want to waste a lot of time. Let's go straight to the business case scenario. Now, for this business, we have collected feedback from 120 customers. We've collected 5 performance variables and 3 demographic variables. Demographic variables are age, gender, and region. Age is numeric, gender is categorical, male, female, written in text. Region is also written in text, north, east, south, and west. While the other um, performance variables are product quality, customer service, pricing, and delivery speed. So the customers are asked to rate this from 1 to 10. Well, what we want to the overall we want to check how does these variables, how do they influence customer satisfaction. Now we want to answer 5 business questions. The first one is, what is the distribution and central tendency of key business performance variables? The second one is, are the data variables normally distributed? The third one, how are the independent variables correlated with customer satisfaction? The fourth one, what variables significantly predict customer satisfaction in a regression model? While the last one is to check the customer satisfaction by gender and region. Right, so the rest of the document tells you the steps that were taken, the interpretation for the outcomes, and business decision made from the outcome. All right, so this is the data that we'll be using. We have the age. The first column is age. It is in Excel format. The first column is age, the other one is gender, region, product quality, customer service, pricing, delivery speed, customer satisfaction. All right, so now we go straight to SPSS. I have it opened here already, and to bring in the Excel file from SPSS, we select File, Import Data, Excel. All right, so here is the Excel. You can navigate to anywhere your Excel file is on your PC, and then you open. All right, so I usually say that to avoid stories, if there are any ways that spaces have been entered in the data uh, data before or after, you can remove them by selecting this two. Then okay. All right, so here we have the data in SPSS. Data in Excel is now imported into SPSS. Now for SPSS, it's a spreadsheet. It's a bit more, it's well, a lot much more scientific than Excel, because here we have to configure, that's in the variable view, we configure what comes in into the data view. So because we export, SPSS has done some configurations by default, and now we want to clean some things up. Now, for example, we have a name. Name is a one word title for each variable. So in case you want to enter 2 words, you use underscore, and it also does not take special number, and it cannot start with values. All right, it cannot start with numbers. So we have age here. For the label, I can type it out as age of customers. All right, gender, I can say gender, I'll just say 6. I'll just say 6. All right. Then product region, I'll just say region. Product quality, I can write product. I don't need underscore here. Quality. Because this is label. In label, you can express yourself. All right. So you are not limited by what you write. All right. Then you have to be careful. Your whatever you write in your label, if you have a label, it will, that's what will appear in your analysis. All right, so you want it to be formal. That's why I'm using capital letter for each word. Here I use product quality. Then I should make it consistent, and my age of customers, I should have capital letter C. Then customer, what's this? Sorry. All right, so customer service, the customer service, have pricing, we have delivery speed, and we have customer satisfaction. All right, so yep, okay, now as aside that, we can also, we have 15 decimal places here, so we can change it, we can reduce it to 2. It's not going to like scrap those ones away. It's just for our viewing pleasure and for our reports not to be in so much decimal places. It just reduces it. All right, so we go back to data view. I see it's in 2 decimal places, and all right, so now let's go back to our business questions. The first thing we want to do is, what is the distribution and central tendency of key business performance variables? All right, so we come back to SPSS, the data view, and go to analyze, descriptives, frequencies, and for the nominal variables, I'm selecting sex and region because they are texts. You can't run analysis for the text and numbers at the same time, because what is required for text is frequency variable, frequency distribution of frequency table, and charts, of which for these other ones you do not need a frequency table for them. All right, so the frequency table is ticked. Then we go to charts and we either select bar charts or pie charts, then percentages, and okay, and then okay. So we have the frequency table: male 55%, 66 of them; male 45%, and 54 of them. All right, so the total for frequency is 120, total for percentage is 100. So you can see it is the labels that show up, not the variable name. So the same thing we have for the region as well, and you can see the charts. So let me quickly dwell on editing charts just briefly. I double clicked to give me the chart editor, and then I have the data label. Select it once, click the bars, select anywhere. You can double click the bars or just pick anywhere, and then click the bar, select one color, and if that's okay, you can close it. There are some other editing, you can play around the editing, and then close this. Then we have the edited charts. It's not as fantastic as what we have in Excel and Power BI, but something. All right, so that's for nominal variables. Let's go to, again, we go to analyze, descriptives, frequencies, then we reset. So now we are selecting the values, the scale variables, and the dynamic is different here. We would like the mean, the median, we don't need more than sum, minimum, maximum, standard deviation, standard error. Well, if you want variance, you can select those things. All right, so I'm unchecking frequency tables because I don't need it for scale variables. Now for charts, I can only use histogram and then show normal curve, then okay. Now for age of customers, on the average our customers are 33.87. The median value is 34. 34 years old. For product quality, the minimum rating is 2.15, the maximum is 10. And so, and our average is 7.0507. So 7 over 10 is still good rating, and so on. You can check for the other variables as well. Now let's go to the variables, the distribution of those variables. You can see this follows a normal distribution. You can check other SPSS videos on this channel to know more about normal distribution. The density plots, that the line, the black line, looks like a bell, shape of a bell. So the more it looks like a bell, the more we say it follows a normal distribution. All right. So the histogram as well, you can see it's having a slopey side by the left, slopey by the right. The middle part is the highest part. Those are the things we consider before we say graphically that a data set or a variable is normally distributed. All right, so we've explored for nominal and scale variables. We've checked the frequency distributions, and we've checked the measure of central tendencies. Those are the mean, median, and so on. All right, so the second business question is, what are the data variables normally distributed, allowing the use of parametric statistics? All right, so one condition for using, there are largely two forms of statistical tests. We have the parametric and non-parametric, and to use parametric tests, they have to be normally distributed, and we've seen here that all of them, they look like the bell shape. That's graphical visual, graphical tests, like visual tests. It satisfies normal distribution. However, we need to check for the formal test as well. Now we go to descriptives and explore, and bring age and products and all of them into dependents, and then statistics, continue, plots. I don't like the stem plots, normality plots, and okay. Then okay. So it gives us a formal test for normality, which by default we use the Kolmogorov-Smirnov test and the Shapiro-Wilk test. The Kolmogorov-Smirnov test is used for small sample size, say 50, 60 and below, while the Shapiro-Wilk test is used for higher sample size, like we have here 120 and above. All right, so now looking at this, the sig values are greater than 0.05, and we say that they are normally distributed. I don't want to go into the theory, but that is how it is interpreted. Once the p-value, the sig values are greater than 0.05, we say they are normally distributed. So they follow normal distribution, or we say they are approximately normally distributed, either one. So now, second business question answered. Now let's go to the third business question. Now that we have established that parametric tests can be used because they follow normal distributions, now the question is, how are the independent variables correlated with customer satisfaction? Again, we go back to an SPSS and do analyze, correlate, bivariate correlation, and pick all of them. You can see how it did not give us string variables. All right, now that's another discussion for another day. Now it's Pearson, we are going by default, and here we have the correlation outputs. Now for correlation outputs, they only range from +1 to -1. +1 being strongly correlated, strongly positively correlated. -1 is strongly negative correlated. 0 is no correlation. And as the numbers, either positive or negative, tends to 0, the correlation becomes weaker. As they go from +1 or -1, as they tend towards 0, it becomes weak correlation. So for example, age of customers and products quality is minus 0.017. That is close to zero. That's what tends to zero means. It is close to zero, so it is low, it is weak correlation, and it is negative correlation. What it means is that as it's possible that as age goes up, the product quality comes down, but not at a significant amount. You can see the p-value is not even significant. It's greater than 0.05. It's almost 1. So it's saying that the rate at which age, like, is not for this business, the way the customers perceive the product quality, it does not increase by age, neither does it decrease by age. It wants to decrease by age, but it's the rate. There's no, it's not really, like they say now, it's not really vibing. It's not really gelling. It's not, we can't really trust that it is reducing or increasing. Yeah, reducing by age because it's negative. All right, so this is 0.16 is also low. Let's look for a high correlation. This is 0.684. This is a high correlation. That's customer satisfaction and product quality, which is reasonable. The higher the quality, the higher the satisfaction is supposed to be. It's not that way all time, but one would think it should be. All right, so here we have high correlation because it tends to 1:1. It is greater than 0.5. This is 0.6. If you want to approximate this, it is 0.7. All right, so now, but however, our interest is customer satisfaction, how it relates with every other variable. So we have customer satisfaction 0.077, and then with age and so on, yep. All right, so that's for the, okay, so for the third business question, we can say that age of the business has weak correlation with customer satisfaction. That's 0.077. Product quality has high or strong correlation with customer satisfaction. Customer service has like mild or weak because it's less than 0.5. So it's still weak correlation. However, it's significant. That means we can trust the value. We are sure of this value. 0.2 is also weak, but we are sure of the value because the p-value is less than 0.05. With delivery speed, it is the correlation value is 0.05, which is low. However, the p-value is 0.5, which means it's not significant. We cannot be sure of this value. All right, now let's go and check the next question, which is on regression, which means which variables significantly predict customer satisfaction in the regression model. All right, so it's, in essence, in simpler terms, it means that which are the variables that affect or influences customer satisfaction. Are we saying that as product quality goes up, customer satisfaction is also going up? Like, is product quality able, people who have high, that rates our products to be highly quality, do they also rate the customer satisfaction to be highly quality? So does this product quality, does it affect this? Does the customer service, does it affect customer satisfaction? Pricing, does it affect customer satisfaction? Delivery speed, does it affect customer satisfaction? All right, so we go to analyze and regression, linear regression, and the customer satisfaction is our dependent variable. Age, we bring it here, and products, blah blah blah, we bring them here. So for now, we just do okay. All right, so for this model, we've seen, because it's what we need, just a few estimates. We have a lot of response, but we need a few estimates out of all of this. Because the independent variables are more than one, we interpret adjusted R square. That's 0.716, which means that all of the independent variables, those other performance metrics, they are able to influence, jointly they influence customer satisfaction by 71.6%. They are able to explain customer satisfaction by 71.6%. Then the ANOVA table is telling us, is the model good? Can we trust this model? Yes. The sig value is 0.000, which means it's less than 0.05. So we can rely on this model. The evidence provided by this data is sufficient. We can go by whatever conclusion this model is giving us. Now, looking at the parameters in the model, we have age, products, customer service, pricing, delivery speed. And age of customers, we have the seed value to be 0.6612. Remember, it is greater than 0.05. So it is not, we cannot trust, despite that the whole model is significant, we cannot trust age of customers. So we bring it out a little. All right. So product quality, it is significant. Every other ones are significant. Now, we know that the product quality, customer service, pricing, delivery speed are significant. Now, which one of them, which one is most important? Which one is better than which one? Which one is the least significant? Then that question is answered by the unstandardized B value. You can also use the standardized B value. They will give you the same interpretation. All right. So for the unstandardized, you can see product quality has the highest value for 0.435. You can interpret it using percentage, say 43.5%. All right. So we have the highest here, and followed by 32.5%, followed by delivery speed, then pricing. All right, so that's how the customers have rated, or that's the outcome of what the customers are saying. Most customers rate product quality more than customer service more than delivery speed more than pricing. All right, so pricing has, although pricing is significant, but according to our customers, they really don't care about our pricing. So that's something we can factor into, so we can decide to test that hypothesis and raise the prices or bring it down to see how our customers are going to respond to it. All right, so that is that. We've seen that product quality is the most important, followed by customer service. All right, so let's look at the last business question, which is, are there demographic differences, gender and region, in customer satisfaction? So we go to here, we go to graphs. We want to see, yeah, we can actually use another test called t-test, but for the case, for the sake of this class, this exhibition, we are just using charts to look at it. All right, so we bring customer satisfaction to y-axis, and then gender to x-axis. I'm going to bring it x-axis. All right, so Autobaska is going to do the mean, give us the mean values per bar. All right, so for female, we have this. I'm going to double click to edit it. Again, go to the label, see the exact label, and all right, so on the average, female, the satisfaction for females are 6.57, satisfaction for male 6.48. So we might want to, if it matters, we might want to target male to satisfy male customers better. Or we can also interpret this by saying that our product is able to satisfy more of female customers. So is it worth it to pursue more females than male? So, but if we want to increase the quality, then we should pursue both of them. We should market both of them. All right, so let's check across region as well. We can come to the previously used charts and chart builder. Okay, I'm going to reset this again. I can drag this or double click it, and customer satisfaction in the y-axis and region in the x-axis, and okay, again I'm going to double click the bars, and here to know the exact values, and close. So now I know that the customers from the west have rated this product higher than customers from the north. The north rated it higher than customers from the south. The south higher than customers from the east. But on the average, they have rated it more than 5, and they all fall around 6 point something. All right, so by region we can see how we have performed there. So looking at this is the fifth business question, and that's all that this demonstration is about. And you can read up all of these files. Okay, don't forget to follow Quiver Analytics, YouTube, Instagram, LinkedIn. Subscribe, like, and comment. Give us good comments and reviews. And thank you. We see you in the next webinar. All right, so and then don't forget, there are other things that we do, the courses, the paid courses, and using different platforms. All right, see you in the next webinar or in the next class.